Thank you for joining this lesson. We're going to study longitudes and latitudes. A and B are 2 points on latitude 40 degrees north. The 2 points lie on the longitudes 80 degrees west and 100 degrees east, respectively, taking pi as 22 out of 7 and r as 6370 kilometers. Remember, r is the radius of the earth. Calculate part 1, the distance from A to B along the parallel of latitude. So we have the two places here. Let me just sketch the Earth's sphere. This is 0 degrees prime meridian. This is 0 degrees equator. Then we are told the two places are on latitude 40 degrees north. So 40 degrees north, 40 degrees north. Then we're going to have one on west, 80 degrees. This is west, 80 degrees. Then the other one is 100 to the east, 100 degrees to the east. So this is where we're going to have our B, and this is where we're going to have our A. We are finding the distance from A to B along the parallel of latitude. This is distance along a small circle in kilometers. So distance along a small circle is usually given by beta out of 360 2 pi r cosine of the latitude where the two places are. So we're going to have beta as the longitude difference, and longitude difference from 80 in the west to 100 in the east. We're going to have an angle difference of 180 out of 360 multiplied by 2 multiplied by 22 out of 7, this is our pi, multiplied by 6370, then cosine of the latitude, which is latitude 40 degrees now, this case. So we're going to compute this, 180 times 2 times 22 times 6370, cosine of 40 divided by 360 multiplied by 7. This is going to give us exactly 15,336.21 kilometers. So that is the distance. The second question is telling us to calculate the distance from A to B along the great circle, along the greater circle. So from A to B, instead of going through the parallel of latitude, now we go through a great circle, which is through the North Pole and back and down to B. So now to follow that route, which is a great circle now, we're going to consider, remember from 0 degrees equator, we have 40 degrees up to the latitude where the two places are. Therefore, I'm going to connect to the axis of the earth such that from 0 to this latitude I got 40. Then from 0 again to this latitude I have another 40. That means now the angle here is 40 and 40, that gives us 80. Then we subtract from 180, so that the angle here is going to be exactly 100. So I'm going to have a great circle whereby the angle at the center of the arc AB is 100 degrees, because from 180 degrees I got 40 and 40. So the angle at the center is going to be 100. Therefore, distance along a great circle is usually given by beta out of 360 2 pi r. So the beta is going to be 100 degrees out of 360 multiplied by 2 multiplied by pi multiplied by radius of the earth 6370. So this is going to give us, when we take 100 by 2 by 22 by 6370 divided by 360 times 7, this gives us exactly 11,122.22 to 2 decimal places kilometers. So these are the distances now along the parallel of latitude and along the greater circle. We continue. Two planes, P and Q, left A for B at 400 knots and 600 knots respectively. If P flew along the great circle and Q along the parallel of latitude, which one arrived earlier and by how much? So we're going to calculate the times taken by these particular planes. We have P, which is having this speed. Because the speed is in knots, it means they are covering nautical miles per hour. So I'm going to quickly calculate the distances in nautical miles. Therefore, along the parallel of latitude, distance is usually given by, along the parallel of latitude, it is going to be given by 60 times theta, cosine of the latitude, whereby I'm going to have 60 times 100 times 180, sorry. The angle difference is 180 from A to B, cosine of 40. So the distance is going to be, when we take 60 by 180, cosine of 40, the distance is going to be 8273.28 nautical miles. Again, distance along the great circle is usually given by 60 times theta, full stop, in nautical miles. So we're going to have 60 times 100 along the great circle. Remember, the angle difference is 100. So 6,000 nautical miles. Therefore, now we're going to consider each plane and the route it followed. For this case, P is having 400 nautical miles, and P is the great circle. Therefore, P is the one covering 600 at a speed of 400. So time taken by P, the time P is going to take, time is given by distance divided by speed. So we're going to have 6,000 out of 400. This will give us 15 hours. So plane P is going to take 15 hours. Time taken by Q. Q is moving at a speed of 600, but Q will be moving along the parallel of latitude. So it's covering 8273.28 at a speed of 600 knots, or rather nautical miles per hour. Therefore, we're going to have 8273.28 divided by 600. This is going to give us 13.79 hours. This is going to give us 13 hours. Then now we convert this into minutes, and 47 minutes. Therefore, the plane which is going to arrive earlier than the other one is plane Q, is going to arrive earlier by, when we take 15 hours, because the other one will arrive after 15 hours, but this one is only taking 13 hours 47 minutes and we subtract, we're going to get the time difference. So this is going to give us 60. When we take 60 minus 47, this gives us exactly 13 minutes on this side. Then now we had borrowed an hour, we have 14, so we have 1 hour. Therefore, we're going to have 1 hour, 13 minutes. Therefore, Q is going to arrive. Then 1 hour, 13 minutes later, we will have plane P arriving. So that is how we handle such a question. Thank you for following. Subscribe and share.